We have two learning targets to discuss today. I can find the greatest common monomial factor of a polynomial, and then I can use a common monomial factor to factor a polynomial. So what we need to know, to find the GCF, or the greatest common factor of a polynomial, we're going to walk through an example together. So this problem says to completely factor all terms of the polynomial. We can use a factor tree if necessary, and we're going to write in fully factored form. So I'm going to do this kind of the long way, just so you can see what's happening, and then I'll kind of give you a set of rules to apply when you're finding your GCF. So when you are factoring your polynomial, it can be helpful to write out your prime factors of your coefficients. So for the prime numbers that make up 4 are 2 and 2. 2 times 2, those are both prime numbers, and they give me 4. And then I write out all of my my x's. I have 6 x's, so I've written them all out here. Next, I have my 20. If I made my factor tree, and for those of you who are more familiar with factor trees, that would be like this 20, and then this is how I would do it. So 2 and 10, and then 10 breaks down into 2 and 5, and those are all my prime factors right there, the 2, and the 5. That's where those are coming from. Then I have x squared, so that's where I'm getting these 2 x's. And then 32, we break 32 down. Again, you could use your factor tree if you'd like. 2 into 16, that's 4 and 4, and then I have to break them all down into primes. So you can see here I have 5 2's. That's where we're getting these 5 2's from here. And then I've got x to the 4th, so x times itself 4 times. Now, when we are finding the GCF, we write each factor that appears in all of the terms outside of a set of parentheses. So every term had a 2 in it, a 2, a 2, and a 2. They all had a second 2, a 2, a 2, and a 2. So here you can see I've written those 2 2's out front because I was able to take both 2's out of every term. Then I look to see, okay, how many x's can I take out? So this middle term here only has 2 x's, and all of the other terms have 2 x's as well. So I'm going to be able to take out x's, 2 x's from each term. So that's where these 2 x's are from. So if that factor appears multiple times in all the terms, you write it once for each time it appears. And then we cross it out if necessary. So everything I've circled here, we've crossed out to show that they're eliminated, they're gone. Okay, we've used them, we've factored them out. So this part out front, this is my greatest common factor. Now, if we want to continue and we want to factor out completely, we write the leftover factors inside the parentheses, so what we haven't crossed out. So here in this first term, we have 4 x's left. In the second term, we have a 5 left. In the third term, we have 3 2's left and 2 x's left. So it would look something like this. Here's my GCF. That's the 4x squared. That was the 2 times 2 gave me the 4, and x times x gave me x squared. And then I'm writing what I had left over. So here's my x to the 4th, here's my 5, here's my 8. 2 times 2 times 2 is 8, and then I had x squared left. You want to make sure that your expression is written in standard form. Remember, standard form is in order from highest degree to lowest degree. This already was because I had x to the 4th first for my first term, but my second 2 terms were not in standard form. I had to flip-flop them to put my 8x squared next, and then my constant, that number by itself, is always going to go last. So let's take a look at 2 examples here. So I'm going to just find the GCF of A. I'm not going to factor it completely. I'm just going to take out what they all have in common. So looking at my number parts here, just the 9 and the 3. 3 itself is a prime number. So I asked myself, okay, can I divide out a 3 from the 9? And I can. So I can divide out a 3. I can bring that out. If I look here, an A, the second term doesn't have an A, so I can't factor out an A. I've got b cubed and I've got b squared. So I can factor out at most 2 b's because I can't take 3 b's from the second term. It doesn't have 3 b's to give. So that would be b squared. And then I've got a c and c squared, so the most c's I can take out is 1. this would be my GCF. Okay, so that's just me kind of walking through line by line. If you need to, you can write out all of the factors. So we know that 9 can be broken down by 3 times 3. Then I had A, I had B 3 times C. And then my second term would have been 3 times BB times CC. So here I was taking out that 1, 3. I don't have A's in both terms. I have 2 B's in both terms. And I have 1 C in both terms. So that is how I got my GCF. Okay, in part B, we want to factor the polynomial. So I have to take out the GCF, and then I have to write what's left over. So when I factor it out, if I look at 6, 12, and 18, what I like to do is look at that smallest number and see, okay, so 6, does 6 divide into 12? And it does. It divides in 2 times. And does 6 divide into 18? It sure does. It divides in 3 times. If you were to divide all of these by 6, I'd be left over with 1, 2, and 3, right? Okay? So this means I can take a 6 out of every single term. Then we look at our variables. I only have x's. I have 2 x's I can take out of this first term, and every other term has 2 x's, at least 2 x's that I can take out. So my GCF is going to be 6x squared. Now, what's left over? So after I've divided 6x squared out, I have essentially nothing left here, but when I divide something by itself, I'm really just left with 1. Here, I took out a 6, so 12 divided by 6 gave me 2. And then I took away 2 of my 3 x's, so I'm just left with 1x. And then lastly, I have 18x to the 4th. I took out a 6, I divided that, so I'm left with a 3. And I took out 2 x's, so I'd be left with 2 x's, so x squared. Now we want to write what's left over in standard form, so I need to put that highest degree first. So I've got to flip-flop this, so it would become negative 3x squared minus 2x plus 1. And that would be my factored polynomial. All right, now would be a great time for you to pause and try these on your own and then come back and check your answers. I'm going to go ahead and factor out the GCF, or find the GCF of this first term. So again, or this first expression here, I've got 2 terms. I have a 32 and a 6. So again, I want to ask myself, can I take that smaller number and can I divide it out of both terms? So 6 does not go into 32 evenly. So that's not going to work for me. And I know that if I look at 6 as factors, if I have my factor tree, I have 2 and 3. So I'm going to try the larger number first. So the 3, 32 and 3, if I try to divide that out, 3 does not go into 32 evenly either. So I'm going to have to use the 2. I can divide out the 2 from both the 32 and the 6. All right, so that's going to be my coefficient part, the number part of my GCF. And then next I'm going to look at my variables. So I have a to the 4th and I have a to the 3rd. So the most that I can take out of either term is going to be a to the 3rd. All right, we don't have 4 a's to take out of this term. I can only take 3 out. And then looking at my b terms, I have b squared and I have b. So the most I can take out of both of those would be 1b. So this would be my GCF, 2 times a to the 3rd times b. Now in the second example, we want to factor the polynomial out completely. So again, I'm going to look at the number parts that I have. I have 7, 21, and 14. I'm going to take a look at that smallest number here, and that smallest number is 7. So does 7 divide evenly into all 3 of these coefficients? Well, it sure does. I'd have 1, 3, and 2 left, okay? So I'm going to factor out that 7. That's going to be my GCF part. And then I look at my x's, my variable parts, okay? So the most x's I can take out of any term would be x squared. So I'm going to bring that x squared out And then I'm just going to write what we have left over. So if I divided out an entire 7x squared from this first term, when we have something divided by itself, that just equals 1. Here, we know that's 21 over 7. That gave me 3 left over, and I took away 2 2's. So I'd have 2 x's. So I'd have 1 x left. And then lastly, I've got this x to the 4th. I took away 2 of them, so there are 2 left. When we divided 14 by 7, that gave me 2, so 2x squared. This is not written in standard form, so I need to do so. So I've got my GCF out front, and then we list them in order of degree. So 2x squared has a degree of 2, except it's going to be negative. I have to make sure I keep my signs. Minus 3x, and then plus 1 because that one's positive. All right, sorry about fussy baby in the background on this. We are finished. If you need more on this topic, you can check out the Learning Target spreadsheet for some additional resources, videos, and practice.